video. Holy cow! There you are. You're back. All right. Pete Giuliano, it is Friday, October 28th, 2022. Pete, what number is that?
241, 241.
Hey,
Crank it
man.
in, Charlie. Crank it in, Robert. Crank it in, Ralph.
Crank it in, fellas. Crank it in. Pete, thanks very much for getting up so early in the morning out there in California. I know it's a busy time for you. We're going to try to get 241 here done because we have a demanding listening and viewing audience, Pete. They want to, they thirst for solder smoke.
Yeah, and it's almost Halloween.
That's right. Almost Halloween. Monday is Halloween. Have you got your costume ready?
Oh, yeah.
Does it include the beret?
I just get dressed up and stand at the door.
I like Halloween. I like it when the neighbors come over, the kids come over. It's kind of a nice kind of community activity. I kind of like it. Hey, people, we got a few things to mention. Another thing happening on the calendar, Mars is approaching. Mars is approaching. We're approaching opposition. Every 2 years, Mars and Earth come into an alignment in which we're closer to Mars than we were at any point during the year. Also, at that point, Mars is in opposition. It's fully illuminated by the sun. It's like a full Mars, like a full Mars version of the full moon. But now I have an Apple Watch. Elisa got me an Apple Watch because she said I was bad at answering phone calls because I sometimes left my phone in another room. So she got me an Apple Watch. Now I have the thing strapped on my wrist. But Apple Watches have all kinds of weird little applications that you could put on the screen. And I actually have a Mars Earth monitor on my watch. Ooh. So I could look at my watch at any time. And it's got a little icon that shows the 4 inner planets and the sun and their relative positions. And it shows us approaching opposition with Mars. Opposition doesn't take place until like early December. But we're getting there. We're getting closer. So every morning I've been going out and observing Mars with my little 6-inch Dobsonian telescope that Elisa got me a few years back. But Pete, I want to mention something else. Look at this. This is one of our props here because we have a viewing audience now. Look at that. Look at that. You know what that is?
Is that a Mars?
It's a Mars globe. It's a globe of Mars. I actually am an owner of a Mars globe, and I did some research on this, and one other prominent radio amateur had a Mars globe. You know who that was, don't you?
The guy with the Ellers Mathis Cup prize?
The old man himself, T.O.M, a guy who had his own acronym, T.O.M, wow. Hiram Percy Maxim. Of the ARRL. He had a globe, a Mars globe, because they were in Mars mania back then. And now I, like TOM, have a Mars globe. I will keep you guys posted as we approach opposition. Hey, one other thing I got to report, Pete, DXCC, baby.
You're there?
Done.
Ooh.
I'm not going for the confirmation thing. I'm just going whether I worked 100 countries, because I put up the hex beam in July, and I said I want to see how long it takes me to work DXCC. And it was longer than I thought and a little bit harder than I thought. But I hit 100 countries a couple of days ago. Now I'm at 102. But it's nice. been kind of fun. It's been fun. The hex beam has made it a lot easier. And there are other things that make it easier these days too. The DX clusters, the fact that you can go online and watch the bands that you're interested in. I'm only interested in 12, 17, and 20. And they tell you almost instantly when a DX station pops up on one of those bands. They tell you exactly what frequency he's on. There's little comments about what he's doing. So, for example, I've learned that most of the South African stations come at us via long path, but it's a real help because it's not like the old days where you just had to constantly spin that dial up and down, looking for DX. Now it tells you right where it is. So. Anyway, DXCC done, and I've kind of pledged to get away from DXing now to go back to more normal, our normal kind of rag chewing activity. But I don't know. I kind of keep an eye on the clusters.
You're bitten by the bug.
I know. Hey, but this is all with homebrew gear too. That's the other thing. And you were the one who mentioned this. But the only rigs I've used in this whole episode were the pandemic plywood rigs. That I built out of the shipping material from the pandemic treadmill. So that was fun. 12 meters was surprisingly useful. I made many of the contacts on 12, many of the contacts on 17. 20 was the real workhorse in this whole effort. So, but it's been fun. It's been good. Hey, another thing to Go ahead.
I just wanted to mention, I was listening briefly to 40 meters last night I just had about 10 minutes, and I turned it on. It was about 8 o'clock. The circuit between Australia and the United States was wide open, 40 meters.
Yeah, 40's been like that. 40, it will open up to down under. You hear South African stations on 40 also. It's usually around gray line period where it's working, but when it works, it really works well.
Yeah.
There's quite a bit of DX there on 40. So conditions are getting better. I mean, it's still erratic, as you've noticed, and there's been a lot of solar storms and things like that. But when it's good, it's been good. It's been better. Hey, Pete. We are on the WayBack machine. We have gone eternal. No one can wipe us out from the internet. They can try. They can try to take us down. The many enemies of SolderSmoke out there can conspire against us, but it will all be for naught because we are on the Internet Archive, the WayBack machine. A while back, there was a story that went around talking about how somebody was trying to archive a lot of ham radio material. And so a number of people wrote to me and said, why don't you propose that SolderSmoke be one of the first to be archived in this way? And I contacted the person, Kay, at the Internet Archive, who's a radio amateur. And she was super cooperative, super helpful. I sent her the files. Dino, KL0S, had a really good kind of show note compilation of all the podcasts. I sent that along too. And boom. We are on the archive. I have a picture of it up. I have a link to it up on the blog, and I feel more secure right now, Pete. I don't think we can be wiped out as easily as some people might like.
No delete key here.
And I can't actually. If I get the fat finger syndrome, I can't hit like the wrong button and wipe the whole thing out. That wouldn't be good. Hey. Sticker news. Lex over there in the Netherlands reports that our stickers are sweeping the old continent, and we feel quite confident that this is quite a revolution. I didn't really know that there's a sticker culture out there, an entire culture of stickers, but there is, and now we in SolderSmoke are participating. So thanks to Lex for doing that, and thanks for Jesse for coming up with the stickers, and thanks for everybody who's been out there putting them up. We kind of need new stickers. I mentioned,
Yeah.
We do. So we look to the sticker community for suggestions on how to improve our stickers. And you guys know who I'm talking to. So think about something and let's come up with some new stickers to continue the campaign. I mean, all these stickers out there, they all can't be about weed and prostitution. There has to be some SolderSmoke in there also, okay? So we're going to try to do that. We're doing our part for American culture, or global culture, I should say. Hey, we got to mention Parts Candy, one of our sponsors, Carlos up there in Chicago. Man, he is making some great clip leads and alligator leads, test leads, things that you need on your workbench. The quote that we've come up with for Carlos's company is "Don't scrimp with a crimp." Many of the other alligator leads that they're selling on eBay and Amazon and other places, all they are is two little alligator clips that somebody, probably some machine, has gone in there and crimp. They put it in that. They don't even take the insulation off, Pete. They don't even have the decency to take the insulation off. Forget about soldering. Carlos takes the insulation off and hand solders that alligator clip to the wire. So you don't have to worry about that crimp. Many times with these old test leads, I would think, wow, that stage is not working at all. And why wasn't the stage working at all? Because the power wasn't making it through the alligator clip, all right? Don't run the risk on that. Don't mess up your whole day. Don't scrimp with a crimp. Go with Parts Candy. Their link is on the SolderSmoke blog page, just on the left-hand column. Just click on the picture there. The multicolored test leads, and you'll be, and Bob will be your uncle. You'll be in good shape. Hey, Pete, I want to talk about what I've been doing on the bench. Let me go first, then you go, okay? First, direct conversion receivers. I think you were partially responsible for the rage of direct conversion receivers that has been sweeping the globe and possibly even Mars. But Farhan in Hyderabad has contributed to this, and Dean KK4 DAS and the Vienna Wireless Society is also involved in this global conspiracy. What's going on with Dean's group, the club that I'm a member of, and Farhan in Hyderabad, is the idea is that DC receivers, direct conversion receivers, are an especially good project for high school students or for anybody who really wants to get more involved in ham radio. And there's a couple of reasons for that. It's a relatively simple circuit. It's kind of a step up from the mate for the mighty midget. It's not that much of a heavy lift. And if you complete the project successfully, you will have built your own SSB your own ham radio HF receiver. And that you will have done something that 90% of all hams never ever do, built a receiver. And believe me, these receivers that we build this way are for real receivers. I mean, if you're listening to one, you can forget how simple the circuit is. It's only really 4 stages involved. And this is something that Farhan always emphasizes. To really understand how ham radio works, you really need to only know about 4 different circuits. A filter, in this case, a bandpass filter. A mixer, various circuits, but we usually use diode mixers. An oscillator, a VFO, and that's kind of an interesting circuit. And the 4th is the audio amplifier.
Be right back.
Okay, Pete, you come on back when you can. Pete's got to jump out. He's got some household duties there to take care of. But I'll continue here. So with the direct conversion receivers, we're just trying to keep it simple. And hold on a second here. There we go. We're just trying to keep it simple. And we've been learning a lot. And so I've got a couple questions about the DC receivers. One, do we really need 100 dBs of gain? That's a question that I have, because I've grown up with the literature saying only 100. You need 100 dBs of gain, but I'm running DC receivers now where the total amplification in the receiver is only about 45 dB, and there's some loss in the filters and the mixer. So the question I have is, do we really need 100 dB? I was just saying, Pete, as you put your headphones back in there, I was just saying, do we really need 100 dB of gain in the receiver? I don't know. This is one of those things where it was just sort of accepted lore, and I had always believed it. But then I built this DC receiver, and I know that I've only got 45 dB of audio amplification, and that's the only amplification in the whole thing. But it works fine. I can hear the band noise. I can hear all the stations. It's fine. One theory that came up at the radio club is that, well, there's just more noise now. So you don't need as much amplification to hear the noise floor. But even though I'm in Northern Virginia, I don't think my noise level here is significantly above what it was, 30, 40 years ago when I started in ham radio. So I don't know. Maybe we could get by. Maybe it's band dependent. Maybe it depends on whether you're using a headphone, earbuds, or a little 8-ohm speaker sitting down there on the bench. But I think it's encouraging because with only 45 dB or so of amplifier gain, you can have a decent receiver there. Here's the other question that comes up. Do you really need to shield the VFOs? Anytime you mention that you have a problem with your DC receiver, somebody will come at you and say, well, you just need to shield the VFO, as if that's some sort of kind of magical solution. But I got a question about that. I have built, and I'm sure you have too, Pete, built many DC receivers, direct conversion receivers, in which the VFO was not shielded, and it worked perfectly well. There was no microphonics. There was no VFO instability. So if it's possible to build them without that kind of shielding, how necessary really is the shielding? So I don't know about that. We've been coming up with some really interesting designs. Farhan is on the kind of the cutting edge of simplicity here. He's coming up with some really super simple direct conversion receiver designs because he's trying to build stuff that the kids, the high school kids in India can reproduce easily. So it's almost a form of munching, of kind of removing unnecessary components and stages. So, I mean, one of the things I really admire is he's come up with a super simple, super stable Colpitts VFO, where the frequency determining capacitor and the feedback capacitor is one and the same. He has like 2 500 picofarad or 470 picofarad caps in series, and boom, the center point is the feedback point. And I was skeptical when I first saw it, but it really works fine. Dean and I have been fooling around with audio amplifiers because we're trying to come up with simplified audio amplifiers. We want to break the tyranny of the LM386, Pete. For too long, we have lived under the thumb of the integrated circuit LM386. And so we've been looking at audio amplifiers that are kind of discrete components. They've got to be discrete. So I built one that has just two N3904s in it in kind of conventional common emitter formation with a 1000 to 8 ohm transformer at the end. Those transformers are getting harder to find, but you can find them. You can find them. Mauser has them. And I built that. It gets about 45 dBs of gain, and it sounds good. It works. But then we were thinking we should be able to do this without using the transformer. So this got me involved in building sort of kind of a discrete component version of the LM386 with push-pull 2N3904, 2N3906 complementary pair transistors at the output. And I got that to work yesterday. And it also produces around 45 dB gain, which is about what you'd get out of an LM386. So I'm pretty pleased with that. It's a little bit more complicated. It takes 4 transistors instead of the 2 that I have in the other one, but you have 4 transistors and no transformer versus 2 transistors and a transformer. So these are the kind of choices that we're having to make. But hey, listen, I want to show you. I've got my props here. Look, this is my version. Let me show. I'm going to hold it up here. Look, this is my version of Farhan's direct conversion receiver. And one of the main features of it, I mentioned the VFO, but we're using permeability tuned oscillators. Look at that. There's a screw that comes in and out. So you turn it. I was skeptical at first, but man, this thing works like a charm. It works good. It's a 3D printed part. So Dean printed me up a 3D printed circuit here. Look, Farhan still has the LM386 in his for the moment, but I'm sure he's going to see the light and reform and get rid of that ugly bit of integrated circuit construction and go back to the pure and beautiful discrete component construction that you see elsewhere in the circuit. I've built mine on a little bamboo cutting board that I probably picked up at Harris Teeter. And there it is. That's the whole thing. So we're trying to keep it simple and keep it fun. I really like the PTO thing, right? Now, let me tell you something, real quick thing about the PTO. How do you determine what frequency you're on, right? This thing turns around many, many times, right? So you can't just put a dial and sort of track the way I used to, right? I'm used to doing that with a variable capacitor. And you've seen my paper and pencil kind of write the frequency and then stick it on the cabinet. You can't do that because it's turned in so many times. So I asked this question. I said, how am I going to solve that problem? The guy who solved it for us was Peter Parker, VK3YE down there in Melbourne. He said something simple. He said, look, just take it and put underneath the screw a ruler and mark the ruler. As the screw comes out, it moves up, right? And if you have a ruler here and you're viewing it from above, you can see where you are. So look here. Here is my dial, my calibrated dial. You could see 7.0 and 7.3 and kind of the intermediate points. But I know that if I look at it from above, I'm looking down on the screw. If the screw is between those marks, I'm in the 40 meter band. I can tell whether I'm down in the CW portion or not. The guys at the radio club at Vienna Wireless were laughing at me the other night with this thing, but it's really a very simple, ingenious solution. So 3 cheers for Peter Parker and for Farhan for pioneering the brass screw PTO thing. One thing, brass screws or steel screws? What do you think?
Brass screws.
Okay. And one of the guys at the radio club said to me, why don't you just put a steel screw in there? So I came home and tried it. I took out the brass screw. We're using quarter inch bolts, and I put in a steel screw in there. And it worked, but not as well as the brass. And I had to noodle on this a bit. The solution is really interesting. brass is not ferrous. So when you're introducing it in there, you're not really introducing anything that changes the permeability of the coil. All you're doing is because of eddy currents in the screw, because it's conductive, you're in effect taking turns off the inductor. So as you screw the thing in, you're making it less inductive and the frequency is going up. However, if you take a steel screw or if you take something in there that increases the permeability, you will be increasing the inductance because it's ferrous, and you'll be pushing the frequency down. But the steel screw is also conducting, so you also have ferry current, you have eddy currents in there. So they're pulling in opposite directions. And this is exactly what I observed. When I put the steel screw in there, it was still changing the frequency, but to a lesser extent than with the brass screw, because you had two opposite kind of physical kind of forces at work. One, you were increasing the permeability. The other, you're increasing the permeability, increasing the inductance. The other, because of the eddy currents, you were decreasing the inductance because in effect you were taking turns off the coil. So it'll work with brass, it'll work with steel. I have in this one now, I have a zinc one. I think I have zinc in there, all right? So zinc is sort of ferrous, and so the same kind of thing is going on.
But I think that there's also a point, Bill, with regard to linearity.
Yeah.
Because the iron-based screw, the relationship between the eddy currents and the permeability change may not be linear.
Right.
Whereas with the brass, you'll tend to get a more linear function. So I don't know if you measured that, but one turn may be 20 kilohertz, another turn, two more turns may be 22, 25.
Yeah.
So I think it's a linearity issue as well.
We have to work on the linearity. I haven't worked on that yet. But the other thing that people suggest sometimes is when you wind the coil, wind it with varying spacing as you go in. In other words, sometimes you'll see these coils where they're wound really tight at the bottom and then they get wider and wider as you go on. That might be a way of affecting the linearity. But we're going to have to turn this over to the PTO International Research Institution, which is headed, by the way, by Nick M0NTV over there in England. I jokingly have appointed him president of the the glue stick PTO research institution, because this is the second thing that's happening. Glue sticks, Pete. I am into glue sticks.
Well, hold on a second before you move on. I have a suggestion for you, kind of a twizzle on Peter Parker's.
Yeah.
You can buy at Amazon little small mirrors. I remember I had one of these as a survival mirror when I was in the service.
Ah, yes.
And if you put the mirror down below, put a band around the screw, and as you advance that, you'll see the reflection of that band. So it's in the mirror face. So you'll see that band change, and then you can put the scale on the mirror face. So I mean, it'd be really cool because then it'll look like it's moving along on the mirror. You'll get a reflection of that versus just a movement on the screw.
All right, so you'd have to put I would put the mirror down below it, like
yes,
the same
yes,
thing.
Yes.
But I would still have to look down from on top, right?
Yes, yes. But the mirror would give a little precision to it.
Well, you've got an idea. You give me an idea here, Pete. How about mounting a mirror or a prism of some sort above, so that I could look at it directly and then go down?
Yes.
That's also possible. People have suggested, and our friend ZL2DEX suggested this, and Farhan came up with it. They suggested sort of a mechanical gizmo where you put a string around the screw, and the string feeds up and goes through pulleys and comes down, and there's a pointer.
S3080.
I mean, it sounds like one of those old Eddie Stone dials, right?
Yeah,
or the Drake 2B dial. And I went back to both of them. I said, well, geez, the mechanism for that would be more complicated than all of the rest of the receiver combined. It would turn into a mechanical monster. But I like your prism and reflector, the mirror idea. So listen, we'll have to turn that over to the Institute for study.
Before you move on to the glue stick, I also crossed my mind, instead of building one DCR, build two. And the reason is, once you get one working, you build two, you now have the basis of an SDR receiver.
I know.
You can take a single VFO output and shift the phase by 90 degrees with a phase shift network, and now you got the basis of your own SDR.
Well, we've been thinking about this. We're taking it one step at a time, but you're definitely right. That is one of the options, and that's one of the beauties of doing PCR receivers with school kids, because you could tell them that it's applicable even in the age of computers. And as a matter of fact, my little Baofeng, look at that. I have a Baofeng transceiver. It's got 2 direct conversion receivers in the front end. I'll talk about the Baofeng in a minute, but you're right. But for now, we're just trying to get them to build the receiver. And there's an interesting idea here we came up with. When we build this receiver with the kids at the local high school, our plan is to build it stage by stage, of course, on separate boards. The very first board will be the VFO board. And the reason is this will give them an immediate feeling of the joy of oscillation. When they finish that VFO board, without having built the rest of it, they'll be able to power that thing up. They have shortwave receivers there at the school, and they have oscilloscopes. So they will have made something with their own hands that produces RF energy. And we think that'll be a real kind of morale kick for them. So that'll be like the first stage of the construction. So it's going to be fun. It's going to be interesting. We're probably going to start after January. But right now they're in the phase where they're giving kids the exams. They've put them through the course, and they're going to take their exams, and they're all going to become at least technician class radio amateurs. So that's going to be great. They're going to get their call signs and everything. So it's kind of a fun project, and we're having we're having a really good time with it. But hey, glue sticks. Glue sticks are the rage, Pete. They are the rage. They are
buy stock.
Buy stock. buy stock in Elmer's. It's pretty scary when you say the future of radio amateurs. The future of ham radio is in glue sticks, my friend. It's almost like the line from the movie The Graduate with Dustin Hoffman way back.
Plastics.
He said, I got one word for you: plastics. So I got 2 words for you: glue sticks. Look, so the idea about the glue stick is it's very similar to the PTO idea, but you take the glue stick, you open it up. Let me open it up here. You got the glue, right? Get rid of the glue. And once you get rid of the glue, just take all the glue out. There's a screw that moves down the center that moves this thing called the cup up and down as you turn it, right? You replace the glue with what I've used as a piece of number 6 or number 2 powdered iron material. And I just put it in there. I wound the coil around this thing. And then as you turn the knob, you're moving the ferrous material up and down inside. And this becomes a true permeability tuned coil. You hook it up to the oscillator, and Bob is your uncle. Then you've got this. Now, one of the problems is you don't have you have no way to read the frequency here because nothing's moving out. You can't use the neat trick with this thing because it doesn't work. But you don't have something moving in and out, which is attractive to some folks. I have one here. Look, I built. I want to show you. This is what I built. Look at that, because I wanted some solid construction. Look, so I took some scrap wood, and I cut out holes about the right size for the glue stick, the Elmer's glue stick. Now, there are various kinds of glue sticks out there. I want to recommend this one, Elmer's giant glue sticks. I got this at Staples. This is important because some of the glue sticks have screws and cups in them where the cup is really loose on the screw. And this you get like backlash or sloppy tuning, right? I tried that with the Uhu sticks out of Germany. No, they don't work this well. Sorry, Uhu, but you're going to lose the PTO market here, my friends, unless you straighten up your act and tighten up the screws. But with this one, the cup seems to fit quite snugly on the screw. So there's no kind of dead space when you change direction and when you're tuning it. So it works out really well. I really like these. And so I've built a number of PTOs on this. However, the guy there are a few people that need to be thanked here. First, Paul Clark, WA1MAC. Paul is the one who sparked this revolution. And he told me, he said he had written to me back in 2008, Pete, I think this was before you got involved, but he wrote to me in 2008 telling me about the glue stick thing, and I must have been busy with other stuff. The kids must have been in school or something. I don't know, but I just missed it, and I didn't pay enough attention to it. The glue stick idea has been around for a while. George Dobbs wrote about it at one point. People have talked about it, but it never really got the attention that it's getting now. And that's really because the attention is coming from Paul, WA1MAC, SolderSmoke, and also in England, the big advocate of glue sticks right now is Nick, M0NTV. Just this week, he did a really good video on his construction of PTO, glue stick PTO oscillators. You really should check it out. Go to YouTube. Just search for M0NTV or Nick M0NTV or glue stick PTOs, and you'll find his video. I'll try to put a link to it up on the blog, but it's really, really cool. One of the questions we had, you know, these bolts on the PTO here, they're 1/4-inch bolts, right? But number 20 thread or number 28 thread?
28.
One is coarse, 20. One is fine, 28. Coarse is easy to get. Fine is harder to get. I think you're right. 20 is the way to go. Why would you say 20, Pete?
No, I said 28.
You said 28. Okay. I started with 28, and then I went and ordered from Bezos number. I started with 20, and then I ordered 28. I got the 28, and I don't really notice much of a difference. It's not. It doesn't. I thought it would be like a big difference. I thought it would be finer, slower tuning. I thought it might the nut might grip the bolt a little bit better. Not much difference. So I think you're okay with either 20 or 28. Either way is okay. Dean came up with an innovation where he put some Teflon plumber's tape onto the screw. And he said that really smoothed out the tuning quite a bit. And it caused also the nut to grab the bolt a little bit more firmly. And that is true. However, that created a problem. It's important to ground the screw physically, to electrically ground the screw to the chassis. So that's what I have this little piece. You can see here, I have this little piece of solder wick that goes in, contacts with the nut, comes down and hits the chassis. That eliminates or helps eliminate the hand capacitance effect. However, if you put the Teflon tape there, it insulates the bolt. So Dean has tried to rub it off. He's had some success, but that is a difficulty there. I just have gotten used to the fact that it wobbles a little bit. I've also put like a board up on one of mine that with a 1/4-inch hole, so it holds it steady. Hey, but enough of the glue stick PTOs. Those who are not into this right now are all falling asleep. But believe me, the future is in glue sticks.
And now let's talk about an SI 5351.
And I have one right here. Look, I never thought that I would own a Baofeng 2-meter 440 transceiver, but I do. Billy got one a while back. Billy got one. Unbeknownst to me, he picked it up and I got it. I think he wanted to use it to talk to his friends, but I found it. He gave it to me, and here it is. And now that I'm more active in the Vienna Wireless Society, they have repeaters. I have pulled this thing out, and I have gotten interested in 2 meters. And you can do amazing things with these little things. And I carry it around. I take it with me when I'm on the bike. I want to put a better antenna on my bicycle so I can go bicycle mobile better with these things. But it's kind of fun. It's neat. You take this around. I've called Dean on it, talked to Dean about our projects and everything else. You know, it's something to consider, Pete. I know you're spending a lot of time in waiting rooms and stuff. You know,
I got one.
Yeah, use it. Try. You know. There's a lot of 2 meters is not really the most friendly band.
No, but it's got an FM radio in it too.
It does. It does. I hit this little button here and it goes to FM radio, and I listen to that. Yeah. So yeah, you might want to give it a try, you know, and it's not all that bad. Hey, Pete, before we get to your bench, Shameless Commerce Division.
Yes.
You know, we're talking about mostly DIY RF. This is Todd, our friend Todd Carney, K7 TFC has started this new company called Mostly DIY RF. And he has got some really fantastic kits there. You got to visit his website. Just go to the right-hand column on the SolderSmoke blog page, and you'll see a link. Just click on the picture, click on the logo. It'll take you to his page. He has made some recent additions to the catalog that he has there. He's selling a discrete component 741 chip. Woo! I like it. Soon, I'm gonna put out a suggestion here. Hey, Todd, how about a discrete component LM386 chip? All right, made with discrete components. That would be fun, and wouldn't be really that hard to do. I've kind of done it already here in the N2CQR laboratories. He's also making available a QER filter kit, which should be interesting for a lot of guys. Also, I want to say something. We have to kind of keep this quiet because no final decisions have been made on it yet, but a Mate for the Mighty Midget kit is in the offing. Mate for the Mighty Midget kit coming up. Pay attention. Check it out. Mostly DIY RF. Check out his webpage. The link is on the SolderSmoke blog. I think it's got some cool stuff happening out there, Pete.
Yeah. Hey, I wanted to talk a little bit about that QER filter.
Yeah.
Because I've had one or two emails with Todd about that, and he's going to sell it in 3 different variants. One is just a plain board.
Yep.
Another one is a board and the crystals, and you put it together. And the third option is he builds the whole thing for you. So I'm not sure where he is in that. But one of the things that I suggested to him was to look at different filter frequencies so that it would give the maximum usability. Like, for instance, everybody's got a 9 megahertz filter. Problem is 17 meters.
It doesn't work too well.
It doesn't work too well. And I said, look at the 49152. And I said, because that works on all the bands and you don't have that problem. And so he said he's been looking at that, and he's also looking at the quantity buys, the cost of crystals. You know, there's some of these crystals are more attractive, and he says if you're buying 1,000 of them, that's big change. 10 cents makes a big difference. So anyway, he's working on that. So if anybody has any favorite filter frequencies, they might email Todd, let him know, because I know he's doing some research on what frequencies would they be provided in. I think he was looking at 11 megahertz, 11068 or something like that.
Yeah. It could be really good, but great suggestions there, Pete.
Yeah. Hey, are you done with shameless comments? Because I had an input on that.
Go ahead.
Yeah. I tripped over this, but have you looked at Bezos and radio standard broadcast and FM radios? Have you looked at any of those?
No. What has he got?
There's a whole new bent in this field. They're building retro radios, the retro cases, but they got Bluetooth in them and everything else. It looks just like something from the 1950s, and it's not one or two. I mean, everybody's coming out with this, and some of these are really cool looking, and they even have an old style portable transistor radio. Remember the first transistor radios came out?
Oh yeah.
But it's got Bluetooth in it, So all kinds of things like that. And so if you're doing some shopping for Christmas, go to the SolderSmoke blog, click on Amazon, check this out. I mean, I looked at, it makes you drool because it's the days of old, but yet it's all modern circuitry inside.
Oh,
so
wow,
I don't know what, somehow they all got together because it's not the same manufacturer. It's a whole series of different manufacturers. So it's really cool looking.
We'll have to check it out. Thank you, Pete, and thank you, Jeff Bezos, for bringing this stuff to us. Bezos comes through again. Yeah.
Yes.
He's having tough times lately, but I think he's going to pull through. He's going to be all right.
Yeah.
Hey, Pete, I know you haven't had much on your bench because you've been so busy with other things. But you got a few things here that you've been working on. You've been hanging in there, keeping that homebrew flame alive out there in Newbury Park.
Well, one of my latest blog postings says my days of homebrewing are probably over. I just don't have the time, and I can tell because there's no hardware coming in the mailbox. There's no parts from Mauser or DigiKey because the time's just not there. So you just you reconcile yourself. I had a lot of fun, but taking on any projects, it's just not in the cards. But one thing that I did want to share, and you had this on the agenda, was the BitX, the BitX 20. It's 20 years old.
20 years old, Pete. One thing that struck me, I saw what you wrote about that. Two things that struck me. One, how long it took me to get in the BitX revolution. I waited about 10 years before I got involved in it. And the second thing was how quickly you got into it, because you built one almost immediately. I mean, I think
Yes.
Farhan put out the schematic, and within weeks or months max, you had built one already. So
Yes.
that was really cool.
Yeah, and I want to share some things that I did. I looked at his design and I said, that's pretty cool. But he had a 10 megahertz IF. And here in the States, I was living in the Seattle area. Boulder, Colorado is not that far away.
Yeah.
I'd be on time every time, with WWV bleeding through. So I put a 9 megahertz filter in there. And the other thing is, I looked at adding an LCD display. So I added an EI9GQ Huff and Puff stabilizer with the LCD. So mine, first one I built, had a digital frequency readout in it, had the electronics, and that VFO didn't drift because it locked in place.
Even then, we saw the roots of Pete's devotion to the SI 5351.
Yeah.
Even then.
Yeah, I covered. The other thing is, I was, when I first looked at it, I said, washers, nylon washers. Who uses nylon washers? Well, that's what was available in India. So I converted all the nylon washers over to ferrite cores, and then I submitted that, and I don't know if anybody used it, but that was in the file section of the BitX20. So my build actually had the ferrite, all the cores converted over to ferrites.
I think I was one of those who benefited from what you just described, because when I built my first BitX, it was for 17 meters, and I didn't use the nylon washers. I did use the toroidal cores that you mentioned. So I probably benefited from that. But one of my favorite stories about the BitX20 is the fact that he was so careful about keeping the cost down, because he was thinking about hams in India, that in the end, you could build the entire thing. If you had to buy every single part, you could do it for about 300 rupees, which at the time was about $5 US. So I took great delight in telling hams here in the United States that I was talking to them on a transceiver, a $5 transceiver, if you wanted. I said, well, I splurged a little on mine, so mine probably cost 40 instead of 5. But $5, and they would find that quite some shocking, and in some cases disturbing, and in some cases unbelievable.
There are two other things I want to mention about the BitX, and this deals with how I built it. At that time, I was using single-sided copper vector board, which is really good for doing point-to-point wiring, not SMD. And I ran out of board, and it was a weekend. So I made my own board.
This is dedication. I took a piece of perf board this is dedication. You're hearing this?
And I hand drilled out all those holes. I went cross-eyed. But there's another point about the design.
Now, did you drill holes that you were not going to use? Did you just go ahead and religiously?
Yes, I did.
All right.
And as a matter of fact, I have pictures that you can see where towards the end there, I got a little, you can see where I sort of came towards the end. But I want to talk about the design. That design is so robust. I pulled out all the 2N3904s that are in that rig, and I had bags of transistors, NPNs, and I just plugged them in there.
You were using plug-in transistors. I remember that.
Yes.
I remember that.
And it worked. There was only one circuit that was touchy that you had to be concerned about. Matter of fact, I have a bag of 2N706s, which is the premier RF device of the early 1970s. I mean, you look at some of the stuff that was built, it has a 2N706 in it. And so I found only one circuit that it didn't work well in. That was in the BFO. And I think the junction capacitance of the 2N706, when you plug that into the circuit, was affected by it. So, but it's a robust design because I had it working with all kinds of weird transistors. As long as they're NPN, it worked.
That's it, because they were feedback amplifiers, because the gain was determined not by the device, but by the feedback network that he built around it, which I agree, that's really one of the best designs. Also, none of those amplifiers were running close to the bleeding edge. None of them were at the point where they were even close to breaking into oscillation. The gain was kept under control by the feedback network, really.
Yeah.
So it was excellent. It was perfect for not only for us, but for the Indian radio amateurs who were trying to build it with very limited test gear, and limited
Substitute
supplies.
anything in there. Yeah.
So yeah, I mean, I really, I've been a
I-
big fan of the BitX all along.
I only found one problem. You found the same problem. Was that wire going from the receive section to the relay?
Yeah.
You're getting feedback, put another relay in, and problem solved.
Yeah, well, it's interesting because Farhan he's such an accomplished engineer, but he's also very much one of us. He's very much the radio amateur, so he's not at all averse to admitting that he changed things as he went along, and that was one area where I think they changed the circuit. One thing you'll notice also in the early BitX, he said that you should take the whole RF amplifier and build it in a separate box and keep it separate. And of course, that changed over time. I don't think you and I ever did that, really. My BitX 17 had the RF amplifier in the same box. And so certainly that was the case with the BitX 40 module that came out, the micro BitX that followed it. All those rigs had the RF amplifier in the same box. But the other thing that's going on, I think Farhan, the original design probably didn't have a whole lot of the gain distribution, OIP, IP3, dynamic range calculations that Farhan's doing now. Now he's doing it, and it makes for, I think, far more robust and far more kind of engineering defensible rigs. But that I don't think a lot of that stuff was happening 20 years ago when he first designed the BitX, which he designed, by the way, as we always say, we always point out,
On the airplane.
in the airplane.
Cocktail napkins.
Calculator and a notebook. So 3 cheers for Farhan and the BitX revolution.
Yeah, absolutely.
I mean, I'm surrounded by BitX rigs. The rigs that I was describing that worked DXCC, 2 of them here are just really derivatives of the BitX. One works on 75 and 20. The other works on 17 and 12. But at their heart, they are BitX rigs. The other thing, one other story about the BitX, I remember I was asking Farhan, I said, look, how can I determine the input impedances that are faced by the crystal filter? Because I have to design the crystal filter, and I need to know what the impedances are on either end, both in transmit and receive. How can I do that? Because they're going to be different when you're on transmit going one way. They're going to be different when you go and receive in the other way. And that's when Farhan told me, he said, look, if you really want to do that, rigorously and carefully, you have to go with TIA amps, termination insensitive amps. It was about that time that Wes and Bob Klopsky wrote their article about termination insensitive amplifiers. And that's where we got into the TIA business. Or you and I used to joke, we used to call them ZIAs. ZIAs or TIA. ZIAs because it's Italian, but it means the same thing, termination insensitive or impedance insensitive. Yeah. So, I mean, great stuff. I mean, the BitX has really kind of revolutionized homebrew ham radio.
The only other change I made is he used 2 diodes in the balance modulator. I used 4. I just have this thing about 4 diodes versus 2.
I know. I mean, I'm having the same, Dean and I are having the same discussion in the DC receivers. I always went with the 2, and they worked fine, but I'm having much better results with 4 in the DC receivers. And I think part of it is in the DC receiver with gain so limited, I do think you have more conversion loss in the 2 diode mixer than you do in the 4. So that discussion continues. But hey, I just wanted to mention also, we mentioned mostly DIY RF. Many of Todd's kits, many of the things that he's selling are spin-offs or kind of derivatives. The TIA amps, he's selling boards for the TIA amps. And this is something that emerged
with AGC.
Yeah, that's it. So, I mean, this is the stuff that's emerged from discussions about the BitX and Bob and Wes's article. So great stuff. So thanks for pointing out the 20th anniversary of the BitX 20.
Yeah.
We should celebrate. We should have like a BitX meeting on the air or something on the anniversary.
There you go. Dig out your BitX. The only other thing that I have a new radio in the shack, the Proficio, which is an SDR radio, and actually you have an opportunity to build one from essentially a board and add the parts. Are all mostly some SMD and through-hole parts, or you can buy a completed assembly. I just don't have time to build stuff anymore, so I bought a completed assembly, and I'm evaluating it right now. But I learned something very interesting with the use of the Proficio. It all depends what SDR software you use. The Proficio comes with an in-house set of software that they develop for the radio, but you can also use it with HD SDR. I've used it with Quisk, and it's kind of interesting to see if you only use one software, you'd say, gee, this is really kind of marginal or lacking. You use one another, say, man, this is really good. So keep that in mind sometimes, that depends on what software you use, the real performance you get out of it. So I'm experimenting with that. But along the way, I needed a computer, a Windows 10 computer, and I found one at Jeff Bezos for $76. A nice Windows 10 64-bit with Windows 10 Pro on it, $76.
Thank you, Bezos.
HP. It's an HP.
And I need one of those because I'm finding that I need a sound studio, Pete. I can't keep doing this in the shack because, like last time, I messed up the audio because I was moving stuff around. Okay, I hope it's better today, but that'd be really cool. But you had some computer woes there. It wasn't all wine and roses with the new computer, right?
Well, yeah. This is funny. I you set the computer up and it was all okay, and then I said, well, gee, I got this in the garage. It'd be nice if I spot something to print it. So I tried to hook into the network printer, and no matter what I did, I could not get it to work on the network printer. It just would not work. And finally, I did some internet research, and I said, well, this isn't going to work because I want to print this out to read it. So I went to my main computer, and I went to the same site, and I said, okay, we'll print this. And I hit the print button, and my main computer said, printer offline.
Oh, man.
The power was off. Somehow I had turned the power off. So the minute I turned the power on, then I was able to link up. But it was really strange because when it did connect, it said, you need to give us an SMA number. I said, what the hell's an SMA number? So it says, and then the instruction says you'll find it on the printer. So I said, I never saw an SMA number on the printer. So I go to the printer, and there is a sheet printed on the printer with the SMA.
You see, Pete, everything you're saying now is an excellent argument for this kind of stuff. I'm holding up the direct conversion discrete component receiver.
Yeah.
And when Pete was telling the story, I sent him. I happened to come across a cartoon, a meme on the internet. It showed you this guy sitting in front of his computer, and he's holding his hands up in triumph, and he says, yes, I got a different error message. I'm making progress.
Yes, I did.
Computer woes.
Yeah, sometimes the not so obvious is the obvious.
I know. My printer will turn itself off periodically, and I have to remember to go turn it back on. It's trying to help me. It never
occurred to me the printer was off. I just thought there was something that it wouldn't, other stuff that I've done that automatically recognized it. One final thing is you sent me a picture of a guy that was building a nostalgia shack.
Oh, yeah, I saw that.
Nostalgia shack, and this nostalgia shack that he was building had a Henry Radio Tempo 1, had a sideband engineer's SBE 33, and a national radio NCX3, and he had them set up there, and he had a shelf, and he was operating these different mediums. And believe it or not, I've got one of those, each one of those, 3 of them. But with judicious shopping, the total bill was $199 for all 3 pieces. So I mean, if you can do some shopping, and some of them will need a little repair work. Now the Tempo 1 was just full of crap, and I had to clean the whole thing up. But the radio works. They all work. You compare them. Actually, I compared to some of the homebrew radios I built, and some of the homebrews work a lot better than those commercial boxes of the 60s.
But the good thing about those old radios is that they actually, even in CW, have character. They have personality. And I know this because lately I've been just listening with the direct conversion receiver on 40 CW. I just leave it on sometimes. And every once in a while I'll walk in the shack and I'll hear the CW coming out. The CW is perfect. The guy is obviously knows how to grab the telegraph key, but there's a little bit of something different in there. You can't say it's chirp, you can't say it's click. It just sounds a little bit different from the mass-produced commercial rigs. So what I will sometimes do is I'll jot down the call sign. Then I'll go to qrz.com and I'll look it up. And sure enough, he's got a boat anchor station. He's got some really interesting old piece of gear or a homebrew piece of gear. And I'll say, man, that's 3 cheers for him, you know? And so that's great stuff. And I was glad to send you that picture. I'll continue to send you that stuff every once in a while, Pete.
And of the 3, only one has a linear dial. Temple 1.
Well, the linear dial, it was possible. They could have done it, but they didn't all do it. Like you always point out, why didn't they do it? The solution was there. And they didn't even need special capacitors. They could do it with regular capacitors, just if they chose the padding a little bit more carefully.
Yeah.
You know, the Hammerland was, I think Hallicrafters were particularly bad with that. Who did the SP600?
The Hammerland.
Hammerland, yeah. The Hammerland SP600 was, I think, was pretty bad in that regard. It would all bunch up at one end, and it didn't have to. They could have done it. I mean, Drake did it. Hallicrafters did it with the HC37 linear, very linear. Drake, very linear. So it was possible. And none of these guys were using any real specialty capacitors. It was mostly just a matter of padding and trimming.
Yeah. Finally, thing on the bench, I was contacted by a ham from China. And
I saw that.
Interested in building the simple SSB transceiver. And I willingly shared the information with him, but I also put a caution there and said, look, I better not see this as a commercial project without recognizing this came from me. I said, one of your countrymen is pursuing my direct conversion receiver design, and it looks like it may end up a commercial product. And I said, you know, I did all the hard work. and all they did is copy the design and produce it. So I said, you know, I willingly do this, but I do want to caution you that you saw that the email.
Yeah, I saw it. And he said, he kind of just said, but that's not me. And I understood what he was saying. I thought it was pretty cool you were getting contacts from China like that. I mean, we get very few. You know, one of the questions I've always had is, why do we see so few Chinese radio amateurs? For example, I'm watching the DX Spots page all the time. I come into Shack since I got into my DXCC thing there. I have not seen a single Chinese station on there in the last 3 months. You see everything else. You see Indonesia, lots of Japan, lots of Australia, lots of Africa. Not a single Chinese station. But I got some insight into this at the Radio Club meeting. I was talking to one of the Radio Club members, Ron Payne, WA6YOU, who spent a lot of time during his working years in India. And I said to him, I said, hey, Ron, how come I see so few Indian stations on the spotter page? Because it's a huge country. It's right over the pole. You know, you could do it long path or short path, and you should see more of them. I see Indians there, but it's infrequent. And he just said, hey, it's a country with, 1.3 billion people in it, and there are 16,000 radio amateurs. 16,000 out of 1.3 billion. He said it's just really difficult to get a ham radio license in India. He said it's like they do all kinds of investigations on you. You have to have all kinds of paperwork. It's very difficult. So it's just really there a matter of numbers that it's hard. So I'm sure a similar dynamic, but with big differences, has taken place in China. But it's a shame that we don't see more activity from China and India. It'd be great, because it'd be wonderful to work all these DX stations. But I'm glad you were in contact with the Chinese radio ham. That was kind of interesting. Hey Pete, let's do mailbox before you have to cut out, man. We got to get it done here. We're approaching the 1 hour mark. SolderSmoke mailbag. We heard from Ken, NS7V. We're glad you're listening, Ken. Thanks very much. Graham, G3MFJ, sent me Sprat on a stick. I guess you got one too, huh? Really cool. Very good. Thank you very much, Graham. And thanks to GQRP. Again, if you're not a member of GQRP and not getting Sprat, what is it, Pete?
You're wrong.
Yeah, so get right.
hey, and that works too. I immediately went to 187 and There I am, right on
There
the
you
cover.
go, man. There you go. 187, the beginning of the Giuliano era here at SolderSmoke. That's great. Hey, a guy that I've been hearing from that we've been talking to for a long time is Dino KL0S down in Williamsburg, Virginia, and I had mentioned several times my HP 8640 signal generator. He talks about he built a number of years back the HP 8640B Junior, which was something that Wes Haywards had designed. It's basically a simple signal generator, kind of almost like, it's not really a version of the HP 8640, because the HP 8640, man, is a piece of work, but it does the same kind of stuff. I mean, HP's 8640 has like a 240 gigahertz cavity oscillator in there at the root, and everything else is derived from that. So it's really an exotic piece of gear. Hey, but I spoke to Dean's Radio Club Builders Group. That was a lot of fun. And they sent me this fantastic mug, the K4RC mug, with my name and call sign on it. I have it displayed here prominently. Thanks very much. And I mentioned that Dino had sent the show notes for the archivization, the immortality of the SolderSmoke podcast. So there we go. I mentioned Nick, M0NTV, now president of the Glue Stick Permeability Tuned Oscillator Research Institute in England.
He's such an interesting guy when you look at his YouTubes, but in his day job, he's a minister.
I didn't realize that. Well, he follows in very good steps there with George Dobbs.
His email is Nick the Vic, and the Vic is he's a vicar.
I didn't realize that. Wow.
Yeah, Nick the Vic.
But he is really an impressive and a prominent home brewer. And listen, he has a spectrum analyzer.
Yeah.
I want a spectrum analyzer. All I got is a tiny SA thing. Pete, you want a spectrum? Do you have a spectrum analyzer?
No.
Oh, we need one. We need two.
Well, actually, I do have one.
Oh, okay.
And it's part of the SDR setup.
Okay.
One of the software, you click on that and it becomes a VNA.
Yep. I want to get one too. Okay. So we'll work on that. I got the tiny SA. Mark Alpha. Oh yeah, wait. Nick also put out recently. Nick put out something on his Shelf 17.
Nice
rig. Good work, Nick. Terrific stuff.
Did you notice what he used? Big L brackets, and he drilled a hole in it, and it becomes like a control thing. So
I really like that. I want to do something similar for the RF connectors, for the UHF and the BNC connectors on the back. I want to get something like that. Yeah, it's great idea.
Sturdy.
Good stuff from Nick. Check it out. It's just go to YouTube and search for M0NTV or Nick the Vic. Nick, you'll find his website there and his YouTube channel. Great stuff. Mark Alpha 7 Tango Alpha recently read the SolderSmoke book. Really liked it. And like a lot of people, found that things in there that he could really identify with. So thanks for letting us know about that, Mark. Steve, Echo India 5 Delta is putting out the Connaught Regional News Magazine.
Ooh, nice.
Wow. I mean, it just made everybody envious. Everybody who read it said, wow, I wish my radio club would put out a magazine like this. All kinds of great technical content in there. Great stuff. And I think I have on the blog, I talked about this and where you can get the link so that you too can receive the Connaught Ireland Regional News, covering all the radio clubs in that section of Ireland. Great stuff. Dave, KAWPE, he said Dave always sends us these really nice, thoughtful messages. I always like getting them. And the one he sent was about planting seeds in ham radio, about sometimes you plant the seed and you don't know where it's going to go. And then later on, you find out that it launched somebody into a lifetime of hobby and ham radio and great stuff. Thanks for sharing that with us. I mentioned Peter, VK3YE down there in Melbourne with his really excellent idea for the ruler frequency readout, which has now been modified by Pete Giuliano with his suggestion that we use mirrors and a prism. We'll work on that. Thank you, Peter, for that. Michael, we get a lot of great messages from Michael, AG5VG.
His PTO.
He made a PTO. He did.
Yeah.
It was fantastic. A glue stick PTO. He made it, and he put a video up there. Again, search for Michael's videos. Just search for AG5VG or glue stick PTOs. I mean, how many videos could there be, right?
Yeah. One thing about his video, he showed you an oscilloscope of the output, clean.
Clean all the way through.
Stable.
I know. I know it made you, an SI 5351 guy, reconsider. Pete's about to go glue stick on us here. Somebody was, I think it was Dean, was suggesting that I've been so deeply into glue sticks that perhaps I've been sniffing the glue. No. Then we've been getting some great email from Tobias Feltus. He's a polymath and he's got UK and Italian connections. Great emails from him. And I think he was he the guy who got the Hedy Lamarr tattoo?
Yes.
Yes, there you go. A Hedy Lamarr tattoo and a tattoo of a radio antenna and a tower. Cool stuff. Thank you, Tobias. We got some nice email from our buddy over there in France, Alan, F4EIT. He is also building DC receivers. There's also in Germany, DC receivers are being built. DC receivers, Pete, are sweeping the globe. Also, the guy in China, or who may be commercially, somebody, not him, but somebody may be commercially reproducing yours. I got an email from Michael S., no call sign, but he said that he was reading the SolderSmoke book and he saw that he was in the Marine Corps about the same time that I was in the Army, and we were both working on equipment that is basically known as pulse code modulation with time division multiplexing. And I remember trying to fix those things. And so it was good to meet up with somebody who was doing something similar. Hey, Alan Yates. Alan Yates is an Australian radio amateur who's done great stuff. Lately, he hasn't been doing a whole lot of ham radio stuff. I think he moved to the States and is working out in California or somewhere on the West Coast. But Alan was the guy who inspired my early build of the trivial electric motor, which was really a homebrew electric motor. Billy and I made it when he was a little kid. Great fun. I still have bits and pieces of it around here. But we were researching some transformers that Dean found on Amazon. Amazon was selling these transformers, little red transformers, and they promised to be 1,300 to 8 impedance transformation, right? Whoa, we bought them right away. It was like $5 for 5 of them or something like that. Dean got some, I got some, and I plugged them into one of my receivers, and it wasn't working so well. Wasn't really doing it. So then I looked in the comments section under the Amazon sales page, and there's a very thoughtful, technically well-reasoned argument there about why these transformers are not doing what they're advertised to do. And it came from Alan Yates. And as soon as I saw Alan Yates' name on there, I said, man, this is for real. This guy found the problem. And Alan described it exactly. So basically the problem was if you hung 8 ohms off one end, it wasn't going to look like 1,000 ohms at the other end. It was going to look like 200 ohms, which has a big significant difference there. So thank you for pointing that out, Alan. Alan, we wish you'd get back into ham radio. We also get great comments from Todd, VE7BPO, who is sometimes known as Vasily Ivanenko. All right, Todd gives great comments. We love all of his comments on the blog. Thanks very much, Todd. Todd is a really proficient home brewer, recently gone into radio astronomy, and he runs the QRP Home Brewers Popcorn QRP website that we've seen. On the YouTube channel, Dale W4OP has come in, providing comments on all kinds of different things. I've gotten an email from Wes W7ZOI. This is one of the great things about the hobby is that you're in contact with people who are at the cutting edge, who played really historic roles in developing and building some of this stuff. And we talked earlier about Farhan. Farhan, listen, Pete, Farhan sent me an SBitX. He sent me one. I have it still in the box. I'm going to take it with me to the Dominican Republic. This is going to be one of my Dominican wintertime projects there. Also, we mentioned Todd, K7TFC, and his mostly DIY RF, but Todd also made a plug for a book, Analog, Real Things and Why They Matter by Dan Sachs. One final thing, and then we got to get out of here, Pete. Jim Olds, my buddy, he's down in Arlington, Virginia, and he built a QRP transmitter, and I think he was working on a DC receiver. But Jim is a neuroscientist and provides a lot of good advice on that field. My son is working in the field, so I'm always happy to talk to Jim about what's happening in that area. Pete, that brings us to another end of an episode. Yes. I thank you for getting up so early and for making such use of your very limited spare time. But thanks very much, Pete.
You bet, Bill, and happy Halloween.
Happy Halloween. Don't
Yes.
scare the kids, Pete. Don't scare the kids.
No, but I did buy an extra big bag of candy because it's not all going to get put out, and that means I get some.
Wear the beret, my friend. The
Yes.
beret is key.
Yeah, and sunglasses.
The beret and the sunglasses. That's
There you go. Hey, 7-3s for the left coast.
7-3s from Northern Virginia. Thanks,
You
Pete.
bet.
Thanks, guys.
Bye-bye.
Bye.